Hello guys, welcome to the new session on data structures and algorithms. So we have seen in our previous videos some core concepts related to time complexity, right? Like what are basically the notations of time complexity, and we have seen the best case, worst case and average case. And along with that we have, also seen some of the basic time complexity examples like big O of n square, big O of 1, big O of n, like this, right? So in this session we will try to clear all our doubts regarding time complexity. We will take one example and we will try to find out the time complexity for that example with a simple trick. Okay, whichever could be the example in the future things, you can easily solve that example and find out the time complexity for it. Okay, so first let me write that example. After writing that example, I'll explain you how we can basically find out the time complexity for that. Okay, so let me write the code for it. There is a simple for loop where I is starting from 1 and I is something like n, and here I star is equals to 2. Okay, so this is the code, and here let's say there is some constant operation, okay, like addition or subtraction, something like that. No, so let us assume that this for loop is let me let us assume that this for loop is under a function called as fun, and in this function we are passing the input as n value. Okay, basically this is our function. Okay, so the question is find the time complexity. So what we can do to find the time complexity, right? So basically we need to represent time complexity in terms of big O. Okay, so that will be your answer. So now I'm going to explain to find out this time complexity using a tabulation method. Okay, so let me write that tabulation method here. The idea is very simple. You need to take two things. The first thing is I value. Okay, because our for loop starts with I, right? Like the entire for loop is run by this I value, so that's why I'm taking the I value. And my second thing will be number of times the loop is running. Okay, number of times. Okay, so I've taken two columns, I and number of times. So let us see how what we can do basically now. If you clearly see, I is starting from 1. So I'll write 1 here. Can you tell me how many times this loop will run for I equal to 1? You can clearly see for each and every I value, whatever may be the I value, the loop runs for one time because it's a constant operation, right? So that's why I'm telling 1 here. Okay. That means on an average, that loop for I equal to 1, it runs for one time, right? In this one time only, those constant operations like addition, subtraction will happen. Okay. Now what will be your I value? Here I is not I plus I plus plus. Here you can clearly see your I is multiplied with 2. That means I is nothing but I into 2. Now your I becomes what? 1 into 2. 1 into 2, which is 2. Can you tell me how many times now it will run? Again it will run for one time only because it's as simple as that. Whatever your I value is running till n times, right? That means for each and every time that means every time it's running for one time, right? For n times it runs for n times, but we need to find out whether it's running for n time or not. For that I'm writing here 1 here. Okay, what will be your next I value? It will be 2 into 2, that means 4. Now again it runs for one time. So you can clearly see by this time the loop has run for one time, by this time the loop has run for two times, by this time the loop has run for three times. Just I'm writing summation of it, right? Like you can see here it has run till one time, and here you can see 1 plus 1 two times, and here you can see 1 plus 1 plus 1 three times, like that. And what will be your next I value? It will be 8, and it will again run for one time. So by this time it would have the loop would have run for four times. So this is the idea, right? We are making a table here. Now this will run for how many times? You need to find out. And this will run for how many times? You need to find out, right? So you can clearly see there is some puzzle here. It is 2 power 0, and it is 2 power 1, it is 2 power 2, it is 2 power 3. So you can clearly see your I is running for how many times? 2 power k times. If I assume this k to be some random integer, you got to know that your I is running for 2 power k times. Now, how many times? That means if I value is something like 2 per k, like k could be anything, right? It can be 3, 4, something like that. But how many times your loop is running? This is the main thing that you are going to find out. This will give you the answer, okay? I value can be anything. I can be plus plus or I can be I into 2, whatever may be. But you need to find out how many times the loop is running. You can clearly see 1 time, 2 time, 3 time, 4 time. So at some point of time, let's say for k, just like we took here k, this loop will clearly run for how many times? K times? No, it is k plus 1 time. I'll tell you why it is k plus 1 time. You can clearly see that, for 2 power 0, for 2 power 0, it is running for 1 time. And for 2 power 1, it is running for, I mean, when it gets to 2 power 1, the loop has already run for 2 times. And for 2 power 2, when it comes, the loop has already run 3 times. You can clearly see for each and every 2 power value, the loop is running for 1 extra time, right? That means for 2 power 0, 1 time, for 2 power 1, 2 times, for 2 power 2, 3 times, something like that. So for 2 power any value you take, it is running for more than that value. That means 2 power 0 in the sense it's 1. 2 power 1 in the sense it is 2. So 1 more than something, right? So that's why I've written here k plus 1. Okay. That is the idea. Here you have seen 2 power 2, but it's running, it has already run for 3 times. So something like that. I'm writing an in detail mathematical equation, guys. Okay. Don't get confused here. So we got to know that on an average, the loop runs for k plus 1 times. So that's it. We got our answer. The answer is k plus 1. But wait. We need to represent the time complexity in terms of n. But you got here k plus 1. Now what can I do? You can clearly see one small equation here. When will your I will stop? When I becomes equal to n, right? When I becomes equal to n, then your loop will definitely stop. What is this I value? I value can be anything in the power of 2. That means your I value is 2 power k. It is as simple as that. So 2 power k equal to n. I'm just substituting everything, right? Your I will stop when it reaches n. You can clearly see in the question, in the code. So when I is 2 power k, then simple. I'm writing it as 2 per k and I'm equating with n. So from this you can get the value of k, right? What is the value of k? If I push this 2 towards this side, you can clearly get a logarithmic log n base 2. So that is the idea of this question. Now you got k value. You got to know k value. How you got to know k value? With this simple funda. Clearly you can see your I will stop when it reaches n. What does I mean? I in the sense it is a power of 2. So that's why I've written 2 power k equal to n. So from this you will get the k. What is the need of calculating the k value? Your answer is actually k plus 1. But you want in terms of n. So I can write k plus 1 as something like log n base 2 plus 1. So this is your actual time complexity. If I neglect this lower order term, that means a constant one, your complexity will be what? Big of log n base 2. So it is as simple as that. You have found out the time complexity for this, right? So the idea is very simple, guys. The main core of this problem is this part, number of times it's running. You simply taking I value and you're taking each and every like 3 4 values you're taking, and after that you're checking for how many times it has been running. Of course it's running for one time only for each and every I value, but you're just checking the summation of it. That means by the time it reaches for the second iteration, it has already run for 2 times. By the time it reaches the third iteration, it has already run for 3 times. By the time it reaches the fourth iteration, it has already run for 4 times. So you can clearly see by the time it reaches the 2 power k iterations, it would have run for k plus 1 time. Why plus 1? Because it is 2 for 2 power 0, it's running for 1 time. So for 2 power k, it will run for k plus 1 time. So it's as simple as that. So our idea is what? K plus 1 is your answer. On an average or completely we can say that this for loop runs for k plus 1 time. But we want to represent time complexity in terms of n. So that's why we have taken a small, easy puzzle that we have found here. I will be I will get stopped when it reaches n value. So that's why we equated I with n, and I in the sense it's nothing but power of 2. So that means it's nothing but 2 per k. So from this I have got the k value, and finally I have substituted that k value in this part because this is our important thing. So from this we have got the complexity and we have made it as big O of log n base 2. So this is a simple approach, guys, to find out the time complexity. Whatever may be the problem, just take these two columns, write the LHS part, write this RHS part, and also try to write how many times the loop is been running. That means by the time it reaches the second iteration, it has already run for 2 times. By the time it reaches third iteration, it has run for 3 times. So by the time it reaches for 2 per k, it will run for k plus 1 times, and this k plus 1 is your answer. And check here if there are anything that will make you find out the k value. From that you can simply say what is the time complexity. So this is a simple approach, guys. For any code snippet, you can use this approach to find out the time complexity. It hardly takes 5 minutes. Okay, so in our upcoming sessions we will try to look into more examples and we'll apply the same technique for finding the time complexity, and we'll see manually like is this a correct that means is it providing you the correct solutions or not. Okay, so that was in this session, guys. Thank you for watching. If you like my content, please like, share, and subscribe to this channel. It means a lot for us. And if you are enthusiastic towards the DSA, data structures and algorithms, then please do have a visit on my channel. You can find out many lectures that I have done on based on DSA. Okay, thank you, guys.